done in basically two ways. One is lossless compression. It will preserve the exact image throughout the compression and decompression process. So, text images is to identify repeating words and assign them a code. You will have to go for a repeating words. Like in this example. So, there are some repetitions 0, 5, 8, 7, 0, 0, 0, 0. Now, after compression this will become 0 means 1 0. So, 1 is color changed and it indicates that 0 only once, then 5, 8, then 7, then 0 4 times. This 0 will be displayed 4 times, then 3, 4 and 0 will be displayed 3 times. So, certain coding for repeated characters should be undertaken. So, large blocks of same color, only we will use color and the area for which that color has to be displayed in compressed form, and when uncompressed it will use that color and it will be filled in the designated measurement of the area. Similarly, pattern substitution, this scans data for patterns, substitutes new pattern and it will make a dictionary entry, that is suppose PEER pi, and these whenever repeated, whenever used in the written speech or any digital reproduction of these sentences, like Peter Piper picked a peck of pickled peppers, this whole thing can be described in the codes. We have designated codes star and other signs which will indicate that how to designate PE, how to designate ER, how to designate PI and CK and all that. So, that has to be reproduced further. So, lossless compression, it will preserve the exact image throughout the compression, and when on the after downloading, if it is downloaded, of course, it will result in a fast downloading. It will be downloaded fastly because it is being compressed. The computer processor will take less time to process the less information, and with coding on one side during compression, and when decompressed, decoding will take place. So, this means text images is to identify repeating words and assign them a code, and on the other side decoding is done and those codes are expanded to produce a uncompressed, uninterrupted, continuous original video display. So, in this form it is a lossless, there is no loss occur to the video, even to the quality nor to the size. Second is lossy compression. Now, this will eliminate some of the data in the image and therefore, provides greater compression ratio than lossless compression, but it will result in a some drop of quality. Some quality of the image has to be compromised. It will eliminate some of the data in the image. It will result in a decrease in the file size, but it will also result in the compromise to the quality also, but only which is not noticeable in the moving images. Now, there are some things in the movie which you cannot notice, or the main attraction is the main part of the movie, generally background things and those things which are not being noticed by the audience will be eliminated, or will be eliminated completely, or they will be having a some vague kind of idea. So, in some movies you may see that in the background movies which are not very clear, when fighting scenes are going on, you will notice that the backgrounds are not that clear, because moving images at that time the compression is performed, and those images or background images, they are compromised to retain the small file sizes in the movie. So, data compression are two types, lossless and lossy, and compression is basically recording data so that it requires fewer bytes of storage space. What is compression ratio? Now, this will result in that how much file has gone shrunk, how much decrease in the file size resulted. Compression ratio means it is a ratio to the original file size and to the compressed file size. So, lossless inverse algorithm restores data to exact original form. Examples are GIF, PCX and TIFF. Lossy trades off data degradation for file size and download speed. So, this is much higher compression ratios and often 10:1. Examples are JPEG, which is very common in multimedia. MPEG2 uses both forms of ratios of 100:1. So, this is the data compression techniques and their compression algorithms, which we have discussed in detail. The video compression or decompression programs, they are used because the videos can fit on a single CD and speed of transferring video from CD to the computer can be increased. As I already explained, if our video is too heavy to the system, then we will not have, we will lose interest in that video, and it has to be in the streaming kind of thing, that it should be playable at the same time it is being downloaded. A sequence of 25 frames per second video is about 25 megabytes, you can say, and CD transfer rate is calculated as follow: 1x is 150 KB per second, if it is 10x it is 1.5 MB per second, if it is 100x then it is 15 MB per second. So, to overcome large video size, codecs were developed. Now, this is a codec. Compressed data will be saved in the form of codecs. Whenever we need to display that video using AVI or MPEG file formats, then these codecs will be decoded. These codes should be decoded so that the repeated words or the codes assigned to a fixed pattern or the fixed video frame are decoded and expanded as per original video. Video compression continues. The digital video compression schemes or codecs is the algorithm used to compress a video for delivery. So, compress means you will have to assign a code to each repetition of characters or each repetition of pattern. The codecs then decodes the compressed video in real time for fast playback. So, streaming audio and video starts playback as soon as enough data has transferred. Now, there is a full video in this diagram. This is a full video is there. It has to be downloaded from original source to our system. There is a buffer, memory buffer, where some part of the, depending upon the speed of the processor of our system, some part will be downloaded to this buffer. From buffer when considerable amount of video is downloaded, it has to be displayed on the screen. So, this process goes on. The video is downloaded and the same is continuously displayed on the screen, so that a audience or the viewer will have a continuous uninterrupted display on the screen. When there is a mismatch, system is slower and this is fast, then it will result in the break of display, and this is where the irritation comes in. So, you will need to know that now what are the compression algorithms, or what are the processors, or what are the RAM or cache are used, or what is the graphics adapter card, and what are the various buses that are being used. So, we need to have a better bus structure, bus architecture, better RAM, better cache, better speed of the system, better adapters, better editing softwares, so that, and better compression technique, so that we can able to view a continuous display on the screen. In codecs also, in lossy, there are spatial compression, a digital compression of video data that compresses the size of the video by compressing the image data of each frame. So, compression is done by removing redundancy from data in the same format. Now, there is a grass in the playground. If we remove some parts, some patches, or dilute some patches of the green color into light green colors, then it will not make to the difference in the to the viewer. Rather, the part where the player is being focused has a complete video. So, this kind of images where unimportant frames can be ignored or neglected at some time of viewing are called spatial compression. Whereas, temporal compression is also there, where we will focus on the frames which are being changed. A digital compression of video data that uses similarities of the sequential frames over time to determine and store only image data that differs from frame to frame. Now, this is a complete in the first picture, this is a complete, you can say, quote, and this thing is being changed. So, in the coming frames or video, we will focus on these only, that what kind of change is there. Now, this will remain same, we do not need to display this much of yard quote again and again. So, this will result in a compressed video, this will take less space as compared to this one. This is a bigger image which will take a very much space to be used, but this is all which is not noticed by the viewer. This part will not be noticed by the viewer, only this part is being noticed. So, this they have shown in the ensuing frames of video. So, this will result in this is called temporal compression. So, compression is done by removing similarity between successive video frames. So, the similar part which is this one is removed and not stored or displayed. So, these are the other formats, Microsoft's AVI format, QuickTime, MPEJ, DivX or WMA, video media, Windows media video you can say, which are also used for video displaying and compression. So, standards have been established for compression programs including JPG, Photographic Expert Group and MPG, so Motion Pictures Expert Group. This we have already taken spatial, that how we can temporal and spatial. Here we will only show the new frames only which have got no similarities. So, changes in the image from frame to frame, key frames are identified every few frames, that changes that occur from key frame. So, provide a greater compression ratio than JPEG. So, this is basically the video hardware and software which is being used. So, multimedia PC can be there and they can be connected to the old VCRs, and here there are overlay boards or capture cards which are used for more graphics kind of things, and this is a video digital editing softwares which are very popular. So, in the discussion we have discussed audio file formats where sound, wave, AIFF, MP3, MIDI or AU etc., and in the video file formats we have discussed GIF, JPEG, TIFF, IMG, BMP or MEPEG. The compression techniques were discussed in detail which helps to reduce file size to more manageable levels. Two types of compression, lossless and lossy, and we have also seen spatial and temporal, that is MPEG kind of concepts which are being used for compression of the programs for continuous viewing for the audience. So, my dear friends, this was all about this topic. Hope to see you again in the next series of the topics. Thank you very much.